Welcome to today's class. Today we are going to discuss about AC through pure capacitive circuit. So here you can see a purely capacitive circuit in the figure. Capacitor that is connected to an AC voltage source and a current I is passing through the capacitor. The voltage across the capacitor is given by Vc. So we can write the applied input voltage, which is an AC voltage. We can write the applied input voltage V is equal to Vm sin omega t. Now, what is the charge in the capacitor? The charge in the capacitor is C into Vc. So, we can write the equation as C into Vm sin omega t. The current through the capacitor, that is the rate of change of charge. Current through the capacitor is equal to rate of change of charge, which is equal to dq by dt. So, here you can see the current through the capacitor. Now, applying this equation, that is C Vm sin omega t, here we will get d by dt of C Vm sin omega t. By differentiating, the equation will be C Vm omega cos omega t. Now, we can rewrite cos omega t is equal to sin of omega t plus 90 degree. So, by rewriting the equation, we can write this equation as C Vm omega sin of omega t plus 90. So, what is this? This is the current that passing through the capacitor I. Now, again we can rewrite this equation C Vm omega as Vm divided by 1 by omega c. Why? Because we can write C Vm omega is equal to voltage, that is the maximum voltage, divided by 1 divided by omega c. So, this expression is the maximum current through the capacitor. C Vm omega or Vm divided by 1 by omega c is the maximum current Im through the capacitor. So, again we can rewrite the equation of current as I is equal to Im sin omega t plus 90. So, this is actually the instantaneous value of the current through the capacitor. So, from this we can understand that Im, that is the maximum value of current, and that is represented as Vm omega c or Vm divided by 1 by omega c. So, this 1 by omega c, that is known as the capacitive reactance. This 1 by omega c is known as capacitive reactance Xc. What is capacitive reactance? That is the opposition offered by the capacitance against the flow of AC current through it. So, here we can find that this 1 by omega c is equal to Xc, which is equal to capacitive reactance, and we can rewrite this equation as, by applying omega equal to 2 pi f, we can rewrite this equation as 1 by 2 pi f c. So, this is the expression for capacitive reactance. Now, we can check whether the current lags or leads the voltage. So, here we can take the reference as voltage here, since the equation for voltage is Vm sin omega t. So, it is better if the expression for voltage is Vm sin omega t, there are no additional or minus angles, we can always take voltage as reference. Now, this is the voltage phasor. Now, how can you represent current? We can represent current using this equation sin of omega t plus 90 degree. So, by representing the phasor representation, you have to consider it in anti-clockwise direction. So, here this plus 90, this is in anti-clockwise direction, plus 90 degree indicate that this current, the current that is passing through the capacitor leads the voltage by 90 degree. Current leads the voltage by 90 degree. So, what this indicates? Current I leads voltage V by 90 degree. So, by checking anti-clockwise direction, we can say that current leading the voltage. So, in purely capacitive circuit, current will always lead the voltage, and if it is purely capacitive circuit, the phase angle will be 90 degree. If it is purely capacitive circuit, the phase angle will be 90 degree, and in a capacitive circuit, current will always lead the voltage. So here it is purely, since it is purely capacitive, the phase angle will be 90 degree. So we can again we can explain that in another way as voltage lags behind the current by an angle 90 degree. Okay, actually these two are same. Current leads the voltage by 90 degree, and we can also say that in different way, like voltage lags behind the current by an angle 90 degree. Now what is the expression for power? So we have already found out the instantaneous power expression, that is equal to V into I. So here by applying the equations for voltage and current, it will be Vm sin omega t into Im sin omega t plus 90 degree. So we can rewrite it as Vm Im sin omega t cos omega t. This sin omega t plus 90 degrees converted into sin omega t plus 90 degrees converted into cos omega t. Now using the expression sin 2 theta. Sin 2 theta is 2 sin theta cos theta. Using the expression, this can be again simplified into this form, that is Vm Im by 2 sin 2 omega t. That is sin 2 omega t is equal to 2 sin omega t cos omega t. So we can rewrite it as sin 2 omega t by 2 equal to sin omega t cos omega t. So this is the instantaneous value for power, instantaneous expression or instantaneous value for power, and average for power for one complete cycle will be 0 when we have to integrate. In order to find the average power, we have to integrate from 0 to 2 pi. So as in the case of inductive circuit, purely inductive circuit, this will be also 0. The average power for one complete cycle for a purely capacitive circuit will be also 0. That means that power consumed in a purely capacitive AC circuit is 0. Power consumed by a purely capacitive circuit is also 0. So power consumed by a purely inductive circuit as well as the purely capacitive circuit is 0. Now how can you write the impedance? The expression for impedance is Z. Z is equal to V by I. So here we have another expression, Z is equal to V by I. So by taking that, we have already obtained this is equal to, since this is a purely capacitive circuit, there will be only capacitive reactance Xc. Xc will be only present. So resistive part or R will be 0 since the circuit is purely capacitive. So we can write Z is equal to, the expression for Z is equal to R plus or minus Jx. R plus or minus Jx, but here since there is only capacitive reactance is present, we can write Z is equal to R minus Jxc. So what will be the expression, final expression? This R is equal to 0, this R is equal to 0, and the expression will be Z is equal to minus Jxc only. You have to indicate, since the impedance is a complex quantity, for taking capacitive reactance, we have to take the capacitive reactance as minus Jxc. Please note that we have to take the capacitive reactance as minus Jxc and inductive reactance as plus Jxl. So the capacitive reactance, when you write the impedance as a complex quantity, take capacitive reactance as minus Jxc and inductive reactance as plus Jxc. So here you can see the waveform representation of voltage, power and current. Here voltage, the blue line indicates voltage. Okay, the blue line indicates voltage. Now we have already studied the current that is leading, current is leading the voltage by an angle 90 degree. So how can you find that? Current leading the voltage by an angle 90 degree. So here the current waveform is here. So if you extend that like this is actually current waveform I. So this phase angle will be 90 degree or pi by 2. This phase angle will be 90 degree or pi by 2. So from looking at this phasor diagram, you can clearly understood that the current is leading, because the current waveform is coming first, after that only voltage waveform coming. So the current is leading the voltage by an angle pi by 2. Or else you can also consider it from a complete wave cycle. By considering one complete wave cycle, we can also tell that the current always lead the voltage by an angle 90 degree or pi by 2 in a purely capacitive circuit. So in an AC circuit, consider AC circuit with R alone, resistance alone. So when resistance alone, what is the expression for voltage? V is equal to Vm sin omega t, and I is equal to Im sin omega t. This is the expression for voltage and current for a purely resistive circuit. So what will be the resistance? Resistance is equal to V by I, or we can write it as V is equal to R into I, V is equal to R into I, or I is equal to V by R. I is equal to V by R. And what is the expression for power? The average power P is equal to V RMS into I RMS. That is the expression for average power for a circuit which is having resistance alone. And what is impedance? Impedance Z is equal to only, Z is equal to, there will be only resistance, because reactance will be 0 for a purely resistive circuit. For a purely resistive circuit, reactance will be 0. So what is omega? Omega is equal to 2 pi f. Omega is the angular frequency, omega equal to 2 pi f. And one more thing, when a purely resistive circuit, voltage and current will be in phase. Voltage and current will be in phase. So that is the case of a purely resistive circuit. Next, in the case of purely inductive circuit, in the case of purely inductive circuit, we can write V is equal to I into XL. What is XL? XL is our inductive reactance. XL is our inductive reactance, and we can write XL is equal to omega L or 2 pi FL. When omega equal to 2 pi f, we can write it as 2 pi FL. So the expression will be voltage is equal to IXL and V is equal to Vm sin omega t, and I is equal to Im sin omega t minus 90. Im sin omega t minus 90. So here we can say that the current lags the voltage. Current lags the voltage. Current lags voltage by 90 degree. Current lags voltage by 90 degree. And what will be the average power? The average power consumed by a purely inductive circuit will be equal to 0. And impedance, we can write impedance is equal to, impedance will be only due to inductive reactance. So that will be equal to plus jXL. Since it is inductive reactance, we can express Z is equal to plus jXC. Now in the case of circuit with capacitor alone, that is C alone, for a purely capacitive circuit, here V is equal to I into Xc. V is equal to I into Xc, where Xc is our capacitive reactance. Xc is equal to 1 by omega C. Also we can write it as 1 by 2 pi Fc. So V is equal to I into Xc, where V is equal to, we can write the expression as instantaneous value as Vm sin omega t and I as Im sin omega t plus 90 degree. Here we can say that the capacitor leads in a purely capacitive circuit. In a purely capacitive circuit, current leads the voltage by an angle 90 degree. And we can write Z is equal to minus jXc. If you are writing it as complex quantity, you have to write Z is equal to minus jXc. So, current leads voltage by 90 degree. Current leads the voltage by 90 degree. So, please remember all these equations while doing the problems. So, we will discuss a problem. A sinusoidal 50 Hz current of maximum value of 100 ampere flows through a capacitor of 318 microfarad capacitance. Calculate expression for instantaneous current, reactance of the capacitor, equation for applied EMF and RMS value of applied EMF and current. So, here in this problem, only passive element connected here is capacitor, because they have not specified any other elements. So, from this we can assess that it is a capacitive, purely capacitive circuit. So, it is a purely capacitive circuit, because we have only the specifications and details of capacitor only. So, we can assess that it is a purely capacitive circuit. Now, what is the expression for instantaneous current for a purely capacitive circuit? I is equal to Im sin of omega t plus 90 degree. While doing the problem, it will be better if you take it as Im sin of omega t plus pi by 2, because we are taking these quantities in radians. It is not degrees, we have to convert it into radians, since omega is angular frequency in radian per second. So, it will be better if you represent it as pi by 2. Otherwise, you have to convert this 90 degree into radians. Okay. So, in doing the problem, while doing the problem, try to write the angles in radians. Otherwise, while doing the calculation, make sure that you are converting angles in degrees into radians. So, this is the expression for capacitor Im sin omega t plus 90 degree. Here they have specified maximum value of current as 100 ampere. That means Im is equal to 100 ampere, that they have already specified. And frequency f is equal to 50 Hz. So, we can find omega is equal to 2 pi f, which is equal to 314. Since frequency f is equal to 50 Hz, that is given, we can write omega is equal to 314. So, apply all these parameters here in this equation. Im is given as 100, sin of omega is 314. So, omega t is 314t plus 90 degree. Now, what is capacitive reactance? The equation for capacitive reactance is 1 by omega c. So, by applying this equation, we already know in the question they have given C is equal to 318 microfarad. So, you have to write it as 318 into 10 raised to minus 6, because it is given in microfarad. So, we have to convert that into farads. So, the expression will be 1 by omega c, that is 1 by 2 into 3.14 into 50 Hz into 318 into 10 raised to minus 6. Make sure that you are converting capacitance to farad and inductance to henries, not to millihenry or microhenry, and not to millifarad or microfarad. You have to, while doing the calculation, you have to convert that into farads. So, please remember that. Now, what is the equation for applied EMF? What is the expression or equation for applied EMF? So, Vm, we know that Vm is equal to Im into Xc. Okay, Vm is equal to maximum value of applied voltage will be equal to maximum value of current into magnitude of capacitive reactance. So, by doing this calculation, we are only finding out the magnitude of capacitive reactance. Here, we are only taking the magnitude. Here we are only taking the magnitude. Since we are taking the magnitude, we can directly write it as X is equal to 1 by omega c, and that is equal to 10.01 ohms. So, when getting the value of Xc, we can calculate maximum value of applied input voltage Vm is equal to Im into Xc. Maximum value of input voltage is equal to maximum value of current into capacitive reactance. So, that will be equal to 1001 voltage, 1001 volt. So, if you got this Vm, maximum value of Vm, we can find equation for V is equal to Vm sin omega t, that is 1001 sin 314 t. And how can you find out the RMS value? RMS value will be always equal to maximum value divided by root 2. So, maximum value of Vm is we already got it as 1001, and Im, that is given in the question as 100 amperes. So, Vrms is equal to 70.71 and Irms is equal to 70.71 amperes, and Vrms is equal to 707.8, because the expression for Vrms for a sinusoidal waveform, a normal sinusoidal waveform, is Vm by root 2, or Irms is equal to Im by root 2. Next problem is a capacitance of 40 millivolt, 40 microfarad is supplied with a potential difference of 220 volts. What must be the frequency if the current is to be 2.76 amperes or and 5.53 amperes? So, here capacitance C is given as 40 microfarad. So, the first step is we have to convert it into farad, that is 40 into 10 raised to minus 6 farads. Now, RMS value of V is given. V is equal to, Vrms is equal to 220 volt, that is given. So, what is the expression? Vrms is equal to Irms into Xc. We know that V is equal to I into Xc. For capacitance, for a purely capacitive circuit, we know that V is equal to I into Xc. So, Vrms will be equal to Irms into Xc. What must be the frequency if the current is to be, the first question is A is 2.765 amperes. So, when current is 2.765 amperes, what must be the frequency? So, here we can apply directly in this equation, that is 220 volt equal to 2.765 into Xc. What is Xc? Xc is 1 by omega c. So, Xc is equal to 1 by omega c. So, 1 by 2 pi into f into 40 into 10 raised to minus 6. By doing this calculation, you will be able to find what is the value of frequency. Similarly, you can find the calculation of finding the value of frequency for 5.53 amperes. Here, in the next problem, the current in 2.2 kilo ohm resistor is I is equal to 5 into sine of 2 pi 100 t plus 45 degree milliamperes. Here you have to note that the current is given in milliamperes and the resistance is given in 2.2 kilo ohms. Write the mathematical expression for voltage across the resistor. Here the circuit is purely resistive. So, as we know, V is equal to I into R, we can write Vm is equal to Im into R. So, Im is 5 milliampere. Im is, from the question, Im is equal to 5 into 10 raised to minus 3. So, Im is 5 milliampere and R is given as 2.2 into 10 raised to 3. So, Vm, maximum value of voltage, is equal to 11 volt. And what is the expression for voltage? The expression for voltage, since this is a purely resistive circuit, voltage and current will be in phase. So, the expression for voltage will be same as the expression for current. So, V will be equal to Vm into sine of 2 pi omega t plus 45 degree. 2 pi omega t plus 45 degree, because this is a purely resistive circuit, hence voltage and current should be in phase. So, here omega t is given, that is given in the question as 100 t. So, we can write it as Vm into sine of 2 pi into 100 t plus 45 degree. So that is the expression for voltage. Now what is Vrms? We know that Vrms is equal to Vm by root 2. So that we will get it as 7.78 into 7.78 volt. 11 volt divided by root 2. 11 volt divided by root 2, that will give you 7.78. And the instantaneous value of current, instantaneous value of resistor voltage at 0.04 milliseconds. So instantaneous value of voltage at 0.4 milliseconds. So for this you have to apply this t is equal to 0.4 millisecond. So 0.4 millisecond means 0.4 into 10 raised to minus 3. That is what we have to do here. Only you have to just apply the equation, equation of instantaneous value of voltage. V is equal to Vm sin 2 pi 100 t plus 45 degree. In this you have to substitute for this t is equal to 0.4 into 10 raised to minus 3. So that we will get as 9.47 volt. Here also please do the calculations in taking radians while converting it into radians. Thank you. So please do this, all of you please do these problems in your notebook. Okay, all of you please do these problems in your notebook before next class.